Hi guys, so for today we're going to talk about variable separable DE involving trigonometric functions, and this is a part 2 of our variable separable in differential equation. So if you haven't watched the first part of the variable separable, make sure to first watch that because on that video the examples are basic examples. For today's video will be solving some variable separable involving trigonometric functions. So we have 3 examples for this video, and I hope um, you watch this until the end. Okay, so when we say variable separable, again, we can separate all the terms containing x with the dx and all y in terms of dy. Well, of course, if the dependent and independent variable involves x and y. Okay, so here we are going to solve this variable separable DE. The very first thing we're going to do is to arrange this such that all of the um, terms containing x must be grouped with dx and all terms containing y should be grouped with dy. So if we're going to rearrange this, so I can multiply both sides dx. So we have e raised to 2y minus y, the cosine of x, then dx. This would be dy because we multiply it by dx. So this is e raised to y sine of 2x, then dx. Okay, so we desire that all the terms containing x are on the right side of the equation and all the terms containing y are on the left side of the equation. So furthermore, manipulating this equation, so we have, I can bring down this to this, okay? So by multiplication, so we can separate that. So e raised to 2y minus y, then we have dy here, and I bring this down. So this would be e raised to y, and that is equivalent to sine of 2x. We have dx over, I bring this cosine of x down. So we have cosine of x. Okay, the very next step, after grouping them in terms of dy and dx, we integrate. So as for to solve the differential equation. But take note that we have a trigonometric identity here. So make sure you are familiar with some trigonometric identities. So we have sine of 2x, that is equivalent to 2 sine of x cosine of x. So before we actually solve this, okay, so what are we going to do is simplify first. So what I'm going to do is we can actually distribute the integral here. So we have e raised to 2y over e raised to y. We have dy here. Okay, by properties of integral, we can separate this. Minus the integral of y dy over e raised to y. So this is still equal to this. And that is equal to the integral sine 2x is now therefore 2 sine of x cosine of x divided by cosine of x. We have dx here. And as you can see, the cosine of x would actually cancel. So we have this. This would cancel. Okay, and then we proceed with the integration. Okay, so this is simply integral of 2 sine of x and then a dx. So let's proceed. So if we're going to proceed, let me just copy again. We have e raised to 2y over e raised to y dy minus we have y over e raised to y dy is equivalent now to integral of 2 sine of x. We have dx. So this, we can simplify this further by properties of exponent. So in that, we can rewrite this as e raised to 2y minus y. Okay, dy minus, and this one, I can bring this up by negating its exponent. We have y multiplied by e raised to negative y, and we have dy here. And we can factor out 2 outside of the integral sign because that is a constant. We have sine of x, we have dx. So again, if we simplify this, this is simply equal to the integral of e raised to y dy minus y multiplied by e raised to negative y dy is equals to 2 integral of sine x dx. So this, we can simply integrate this, and that is e raised to y. But this is this part, okay, the middle term, okay, this term, the integral of y multiplied by e raised to y negative y dy is an integration by parts. As you can see, we have a polynomial here, okay, and we have an exponential. So integration by parts suggests that we have to do uv minus the integral of v du, wherein we have to choose u as a y and differentiate u with respect to y, that is equal to dy. The differential, or the derivative of y is simply 1. We differentiate it with respect to y, so we have dy here. So, and then the dv is the remaining term. We choose u as y, so the remaining term is e raised to negative y dy, and if we integrate that to get v, we get negative e raised to negative y. And then, we can proceed now with the formula uv minus the integral of v du to solve this integral. So, we'll be having minus u times v, so that is negative y e raised to negative y if we multiply u and v, minus the integral of v, which is negative e raised to negative y, and the integral, or the du here is equivalent to dy. The du here is equivalent to dy, as we have here. Okay? And that is equivalent to 2 integral of sine, well, of course, that's negative cosine of x. Don't forget the plus c. So, upon simplifying this, we have e raised to y. Okay, later I will distribute the negative sign. So, I can factor out negative here outside of the integral. So, minus times negative would be plus. And we have e raised to negative y dy. And this would be negative 2 cosine of x plus c. Okay? So, we need to integrate this. We know that the integral of this should be e raised to y. Okay? I would still not distribute the negative sign for you not to be confused. Okay? The integral of this is negative e raised to negative y. Agree? Okay? So we have integrate this. That is negative 2 cosine of x plus c. And now we shall be distributing now the negative sign. So that we have e raised to y plus y e raised to negative y, and then we have plus, because that's both negative. E raised to negative y is equal to negative cosine of x plus c. And that should be our answer for this, that should be our answer for this problem. Okay? This is our solution for this variable separable dE. Okay? So let's try another one. For number 2, we have the cosecant of y dx plus a secant squared x dy is equals to 0. Okay? So again, we need to separate this, okay, such that we can have dx over secant squared x plus we have a dy over cosecant of y is equals to 0. Okay, we need to apply some identities here. Okay, as you can see here on the left side of our equation, first term, we have 1 over secant squared x, and that is equivalent to cosine squared x. Okay, and then we have another one on the second term. We have 1 over cosecant y, and that is equivalent to sine of y. So upon substituting these values, we have now cosine squared x dx plus sine y dy is equal to 0. Okay? So, but again, this cosine squared x has its own, okay, identity. Cosine squared x is equivalent to an identity of 1/2 cosine 2x plus 1. So we need still to substitute the value of this on our cosine squared x. So we have 1/2 cosine multiplied by cosine of 2x plus 1 dx plus sine y dy is equal to 0. And then we try to integrate. Okay? We try to integrate. Okay. We know that this is a constant. We can factor it out. 1/2 cosine of 2x plus 1 quantity dx plus, we know that the integral of this, let me just copy, sine of y dy is equal to 0. And furthermore, we can actually distribute the integral sign such that this is a sum. So we have cosine of 2x, okay, dx plus integral of dx. So 1 dx, integral of dx still the same, plus integral of sine of y dy is equals to 0. So what will happen next is that we can integrate cosine of 2x. So cosine of 2x, if we integrate this, that would be, we will be having a correction factor of 2 because of 2 here. So that would be 1/2, okay? Then the integral of, let's say, we have a factor of 2 here, cosine, sorry. So this would be a correction factor of 2 because of 2x. So we have 1/2 outside of the integral. So we can now integrate this because we have already offset a 1/2, the reciprocal of whatever constant is here. So the cosine, the integral of cosine 2x would be what? Sine 2x. Okay, so we have a correction factor of 1/2 again because of this 2. Okay, plus integral of dx is simply x, and plus the integral of sine of y is actually negative cosine y, and we have plus c is equals to 0. So if we distribute 1/2, you have 1/4 sine 2x plus 1/2 x minus cosine of y plus c is equal to 0. So if we multiply both sides of the equation by 4, so what will happen here is we have sine of 2x, 4 divided by 2 here. So we have plus 2x here minus 4 cosine of y plus 4 times c is still c is equals to 0. Okay? So this should be our final answer for this variable separable problem. We know that this has still a trigonometric function. If you want to furthermore simplify, okay, sine of 2x, you can still simplify, but we can accept it as our final answer for this, at least for this problem. So for the last problem, number 3, let's try to solve this variable separable. We have sine of 3x dx plus we have 2y cosine cube of 3x, we have dy is equals to 0. So again, we need to separate, okay, x with the dx. We need to group in terms of x dx and y dy. In this case, for this given differential equation. So we have sine of 3x dx over cosine cube 3x, okay, plus we have 2y dy. We simply multiply the whole equation by 1 over cosine cube 3x. And furthermore, we have sine 3x. We can actually split this into cosine squared 3x multiplied by cosine 3x. Because technically, cosine cube 3x is simply equal to cosine 3x cube. Okay? And furthermore, we can split this as cosine 3x squared multiplied by cosine 3x. And cosine 3x squared is still the same as cosine squared 3x. okay, multiplied by cosine 3x. So we have this relationship. We split down the the cosine cube 3x. So we have plus 2y dy is equal to 0. And again, before we integrate that, as you can see here, sine 3x over cosine 3x, that reminds us of the identity that we have sine theta over cosine theta that is equivalent to tangent theta. So this sine 3x over cosine 3x is now equal to tangent. So we have tangent 3x. So we have a dx here. I forgot to write. So we have a tangent 3x over cosine squared 3x plus 2y dy is equal to 0. We know that if we are going to integrate this, okay, still we need to first transform again this to another trigonometric function. We have 1 over cosine squared 3x. And that is 1 over cosine squared is simply equal to secant squared 3x. So if I'm going to substitute that, that would be, okay, tangent 3x dx. I'm sorry, we have a dx here. Okay, tangent 3x, okay, multiplied by this. Okay, we have transformed this into secant squared 3x. So we have secant squared 3x. We have dx plus 2, factor out 2 because that's a constant. Okay, so we already have that. So what will happen if I'm going to copy, let's copy it, tangent 3x secant squared 3x dx plus 2 integral of y dy is equals to 0. We know that we can easily integrate this. The very reason why we transformed that this 1 over cosine squared 3x here into secant squared 3x because so that we can integrate this. As you can notice, this is a simple u substitution. If we let u tangent 3x, we get the du of that, that is 3 secant squared 3x, okay? But our available here, this would be dx. Of course, we differentiate with respect to x, so there must be a dx here. So as you can see here, secant squared 3x dx is present in our integral, but we don't have 3, so we can offset 3 here. Okay, multiply this by 3, but also upon multiplying 3 outside the inside of the integral, we must multiply outside the integral by the reciprocal of what we have multiplied inside. So that is 1/3. So we have 1/3. So simply, this would be 3 secant squared 3x is our du and tangent 3x is our u. So we have u, that's a tangent 3x, and we have 3 secant squared 3x dx is simply our du. Okay, so if we integrate this, it's very easy. So we have 1/3 power formula. We have u squared over 2 plus we have 2y squared over 2. Okay, and we have, of course, plus c. Don't forget that. So this would cancel. And we know that this is 1 over 6 u squared plus y squared plus c is equal to 0. But again, u is equal to tangent of 3x. So definitely we need to transpose it back, or we need to substitute it back, I mean. So we have 1/6. What is our u? Tangent of 3x squared, okay, plus y squared plus c is equal to 0. So if I'm going to multiply all of this by 6, so I can eliminate the denominator. So we have tangent of 3x squared plus 6y squared plus c is equals to 0. So this should be our final answer for this variable separable d involving trigonometric function. Or we can also rewrite this as tangent squared of 3x, that is still the same, plus 6y squared plus c is equals to 0. That is still the same. Okay? So I hope you guys learned something for today's video. This is very simple. Variable separable of involving trigonometric functions in differential equations. So thank you so much for listening again, guys. And if you are new to my channel, please don't forget to subscribe. And please don't forget to leave a thumbs up and a comment down below. So thank you so much for listening. God bless you. Again, this is Engineer Abat. God bless.